Geometry, Unit 1, Lesson 8. I can identify and solve problems involving special angle relationships. So let's dive right in. Adjacent angles. So a good definition of adjacent angles would be angles that share a ray. Well, let's see what that would look like. So for example, here's one angle, okay? Think of it as angle 1. But then if I do this and call this one angle 2, you can see how angle 1 and angle 2 are different, but look here at the ray that they share. So a lot of people say, though, that adjacent really means next to. So these two angles that are next to each other. But specifically, it means they're going to share a ray if they're next to each other, touching like that. A non-example would be what happens if I put angle 1 right here and angle 2 right here. Are those adjacent? No, because they're not sharing this ray. Now, vertical angles would look like this. Imagine you have angle 1. Say it looks like this. And then what would be the opposite of this ray? Well, it would be that ray. And what's the opposite of this ray? Well, it would be that ray. And you see this angle down here that was made by the opposite rays? These are called vertical. And the nice thing about them is they're also congruent. If you flipped angle 2 on top of angle 1, they would fit perfectly. So a definition for vertical angles are angles that have opposite rays. Now, it's really important to realize that they are congruent. So here, angle 1 is congruent to angle 2. Okay. So a non-example, why don't I give you the same kind of approach, but if I call this one angle 1, let's use this one for angle 2. Are these vertical angles? No, they're not. These would be vertical, or these would be vertical, but not these, because they don't have opposite rays. This ray and this ray are opposite, but not this one. These are actually what? Adjacent angles, because they share that ray. Now a linear pair, if we go in and break this down, you see the word line in there. And pair, you know, is 2. So it's going to be two angles that make a line. So a linear pair actually would look just like we saw over here. So if I say angle 1 and angle 2, they might not be congruent, but together there's two really important things about them. Okay, linear pair are going to be 2, because it's a pair, angles that are adjacent and something we're going to call supplementary. You might be saying, well, what's supplementary? Well, can you see the straight angle here, the straight line? Well, what do you think angles 1 and 2 sum up to? 180 degrees. They sum to 180 degrees. Both of these things must be true. Okay, they need to be both adjacent and supplementary if you're going to call them a linear pair. And that makes sense, because look, when you add them up, they make a line. Two angles that add up to make a line, and they are adjacent. A non-example would be, let's say if I pull this angle out, let me move this angle over here. Let's call this one here 150 degrees. Let's call this one 30. Well, do they add up to 180? Sure, they're supplementary, but are they adjacent? No, they don't share the ray. So if we go and apply this, let's name two acute vertical angles. And I always want to make sure I know what I'm doing. I'm trying to name, so I'm going to use the right notation. I need acute vertical angles. Okay, so they need to be acute and vertical. So 45 and 45 are both acute is the classification, and they're vertical because they share opposite rays. So angle KBH, KBH, and angle GBM. GBM are acute, that's the classification, and they're vertical. Let's name two acute adjacent angles this time. So acute and adjacent angles. Okay, so they have to be acute, so that means they're going to be less than 90, and adjacent. Well, I could say these two, I could say these two, or I could say these two. I just can't use the 135 because that's obtuse. So how about we just use these two angles here. Let's use angle JBG. JBG is 70, so that's acute, and angle GBM. They're acute and they're adjacent because they share this ray. Let's name a linear pair. Okay, so remember, it has to make a line, the two angles, and they have to be two angles because a pair means two. So let's see, a linear pair. Well, here's a straight line, and these two angles make that straight angle of 180. So I'm going to say angle HBM and angle GBM. They make a line, and they are adjacent because they share a ray BM. And finally, let's do two obtuse vertical angles. Okay, two obtuse vertical angles. You might say, well, there's only one obtuse angle. Let's stop and think about it. This angle here is obtuse, but so is this angle. You have to look at the whole thing. This angle, you don't have to look at this ray right here. So this angle, KBG, is 65 and 70 together, which makes 135. So this angle here and this angle here, they are vertical angles. So I'm going to say angle KBG and angle HBM. Okay, so there's really only two more vocabulary words we're going to have to go over, and it's complementary and supplementary. We already talked about supplementary. Okay, supplementary are going to be two or more angles. You could have more than just two. Two or more angles that sum to 180. So for example, we could do this. Angle 1, 2, and 3. All right, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. How do I know? Because, take a look, they all together make a straight line, which we know is 180 degrees. Could be just two angles, it could be 10 angles. As long as they add up to 180 like this, they're supplementary. Also, I could take them apart. What about this angle here? Let's do another example. Let's say this one right here is 80 degrees. Let's say this one here is 100 degrees. Are these two supplementary? Sure, because 80 plus 100 is 180. Notice they didn't have to be adjacent to each other. This is okay, this is okay. They don't have to be adjacent to be supplementary. So what would a non-example be? Well, really two angles that don't add up. How about these two right here, angle 1 and angle 2? You already know they aren't supplementary because these don't make a straight line, so they can't be 180. Or we could do something like this, call this 60, and how about call this 30? Those do not sum up to 180 either. But let's go ahead and look at the other word. That one's complementary. This one means two or more angles that sum to 90 degrees. So instead of 180, we're doing 90. That's complementary. So if I go after an example here, I could do two examples again. Angle 1 here, angle 2 here. Okay, as long as I know that this here is 90, then I know the measure of angle 1 plus the measure of angle 2. Okay, we're good to go. Those are complementary. Or I could pull them apart and call this 30, maybe call this one 60, and I know that these make 90, so they are also complementary. A non-example, really any two angles that don't sum up to 90. And again, they don't have to be adjacent to each other. They don't have to share that ray. So we could just say 20, and how about 40? Those don't work. They don't sum to 90. So if we come down here and tackle these guided practice problems, name two supplementary angles. So I'm naming, so I need to make sure I use my notation, and they need to be supplementary. Well, I'm only allowed to use two, is what it's asking for. So I need to make 180 degrees, and these two here make 180. Maybe I would want to use this one here, and this one. Doesn't really matter. Let's go with this one. Angle HBM, angle GBM. Are they adjacent? In this case, yes, they are. They share. Here's the first one. Here's the second one. And you can see that they share this ray right there. That's why they're adjacent. Now, I didn't have to pick those, though. I could have picked this one right, let me see, how about, well, they still have to add up to 180. So I think I'm a little stuck on that. But I could have picked this one here, and this one here, and so on. Okay, name two complementary angles. Complementary, that's 90 degrees, whereas this was summing to 180. Well, I can see that 45 and 45 add up to 90, so I'm going to say angle KBH and angle GBM. Look at those two. They sum up to 90. 45 plus 45 is 90, so they're complementary. Are they adjacent? In this case, no. You know what they are, though? Bonus? Vertical angles. Look how this ray is opposite of this one, and this ray is opposite of this one. If you flipped this V right here, it would flip perfectly on top of the other one. All right, so let's apply two more difficult problems. What would be the measure of an angle whose complement is 35? If you see complement and think complementary, you're right. Complement is one angle that adds up to another one. It's going to make 90. So for example, what's the complement? Sorry, what's the measure of an angle whose complement is 35? If this is the angle, I don't know, but its complement is 35. Complement means sum to 90. So you know your two angles have to add up to 90. One of them is 35, so if we solve this right here, we end up getting 55 degrees. That is the angle whose complement is 35. Together, they make 90. If I switch the word complement and said instead supplement, instead of adding up to 90, supplement would add up to, that's right, 180. Last problem, most challenging. What would be the measure of two supplementary angles? Okay, so I know supplementary means they're adding up to 180. If the difference, this means minus, in the measure of the two angles is 12. This is pretty challenging. Now, if I know I have two angles, I don't know either one, but they're supplementary. That means if I add them up, they better be 180. That's my first relationship. Now my second one is the difference in the measures of the angles is 12. So does that mean that x minus y is 12? So if x is the bigger one, let's say, and you take the difference and you get 12, these are the two relationships. So I got this one from supplementary, and I just made up x and y because I don't know either angle. And the difference told me to do that relationship. How do I solve this? Well, I'm going to go ahead and add y to both sides here, and I'm going to get x equals 12 plus y. And the good news is I can take this expression and I can substitute it in here for x, because that's what x is equal to. So x I'm going to take out and substitute in 12 plus y. I'm solving a system of equations. So now I can combine like terms and have two y's there. Let's take away 12 from both sides. And now we have 2y is equal to 168. We divide both sides by 2. And y is equal to, I think that's 84 degrees. Am I done? Well, no. I need the measures of two angles. So let's go back and find x. Therefore, x is equal to 12 plus y, or in this case, 84. So our x is going to be equal to 96 degrees. They're supplementary, and their difference is 12. There you are. Look for the keywords to set up your relationships. Good luck.